So we're asked to solve this differential equation by using integrating factors. So this is the nice boiled down version of integrating factors that the textbook has. First, identify your integrating factor, then you can find your general solution using this equation. So before we do all that, we got to put it in standard form. So we got x. Actually, let's divide. This one feels really familiar. I feel like I just did this one, but let's divide everything by x. That way we get y prime by itself. And then for standard form, we want to have the y term over here on the left side. So it's going to be minus 3 over x times y equals negative 8x. So the algebra I did there is I subtracted this from both sides, and then I rearranged the fraction. The fraction is 3 over x times y. Okay? That way I can clearly identify my p of x. This is your p of x, and this is your q of x. So in order to solve using integrating factors, the integrating factor is e to the integral of p of x. So I like to think of the negative 3 being factored outside before I try to integrate. So that's 1 over x dx, and that's a well-known indefinite integral, right? That's natural log of x. So we got negative 3 times natural log of x. And then the negative 3, using the properties of logarithms, can become an exponent. So this is natural log x to the negative 3rd power. And finally, e to the power of natural log x, those are inverses. They undo each other, so we just have x to the negative 3rd here. Okay, so that's our m of x. Now that we know that, we can find the general solution. It's 1 over x to the negative 3rd, so that'll be nice. That's just going to be x to the 3rd times the integral of 1 over x to the negative 3rd times our q of x, which is negative 8x plus c. So this is y equals, I'm just going to simplify this, it's x to the 3rd times this indefinite integral. You can clean it up first if you want to before you try to evaluate the indefinite integral. You get x times x. Oh, actually, sorry, I was about to do that wrong. So take the negative 8 out, and then this is 1 over x to the. No, I've typed this in wrong. So that's what's hanging me up here. The outside term is 1 over m of x. Right? This was this, and my brain just short-circuited because m of x is just supposed to be x to the negative 3rd. Okay, now we get that fixed. Factor out the negative 8, and you get the integral. This is going to be x to the negative 2nd now, because x to the negative 3rd times x to the 1st. And that's a nice easy integral, a lot easier than some of the other ones in this week's problem set. Right, so this is negative 8 times negative x, sorry, let's put that in parentheses, times negative x to the negative 1st plus some constant c. Okay, if you have trouble with that antiderivative, it's the power rule happening in reverse there, so that's the power increases by 1. That's x to the negative 1st, but it needs to have the negative on the outside so that if you were to take the derivative, it turns back into this. Okay. So cleaning up a little bit more, we can distribute that x to the 3rd to everything in here. So negative 8 times negative 8 makes a positive 8. That's 8x squared. And then x to the 3rd times c makes c times x to the 3rd. So there's our general solution.